All right, so this right here becomes 13/4 minus 2. Now, everybody write down what 13/4 minus 2 is. I'm going to see how many people know this answer. 13/4 minus 2. 13/4 minus 2 without a calculator. This is going to be determined whether or not you get to use a calculator next year. Mr. Valdez, what's 13/4 minus 2? Is not good. Wyatt, what is the answer? Good. Good. Finley. Next. Tell him. 1 1/4. What did you get? Miss Rollins. 11/4. Go. Also got 11/4. Let's just jump on the bandwagon. Go. Sadie, what? You're still thinking. Next. 11/4. Next. Miss Vaughn. I don't know. At least you're honest. Go. 1 1/4. Everybody else said 11/4. Why would you say that? Because you'd like the right answer, correct? Yeah, you'd like to say the right answer, not all the wrong answers. Go. 5/4. What do we get here? 5/4. Oh, yeah, 11/4. Amaya. Yeah, now look, come on, guys. I'm a little embarrassed. And you guys think it's funny. I'm not. I think it's embarrassing when someone asks you what 13/4 minus 2 is, and you look at me like I'm crazy. You can think back to 5th grade if you want. 4th grade, if you were in an advanced class, everyone was able to do that. Now, you're all the way in, almost in 8th grade, and you're laughing at the fact you don't know 13/4 minus 2. It's not funny. Not at all. 2 is how many fourths? 8. 2 is the same as 8/4. Everyone should have said 5/4 is the answer. I don't want to say 1 1/4. In advanced math, we don't do mixed fractions. We do improper, although it is correct and you wouldn't be marked wrong. It's just we're going to write it as 5/4. Come on, that's embarrassing, guys. If you said 11/4, that's embarrassing. All right? That is embarrassing. There's no escape. You have to be able to do fractions, which probably means I let you use your calculators too much. All right, so next year we will avoid calculators. Number 39. Everybody should be able to tell me what's 4 cubed. Nope. 64. Everybody write down 64. 4 times 4 times 4. 64. What's 3 squared? 9. What's 5 to the 0? 1 or negative 1. 1 to the 8th. Come on, that's why I'm saying your brain goes too fast. You hear me? It's too fast. Slow down. You'd be a different math student. I mean it. Slow down. You'd get everything right. Because you know everything. You just make all the mistakes. So now what's negative 1 plus 1? Yeah, that's not a trick question. Now, how do I add 64 plus 9 real quick? You add 10 and then subtract 1. What's 64 plus 10? Minus 1. 73. Everybody should know that. There's no calculators for that. No calculators. All right. What do I have to do first in this problem? Tell me. 4 times 6, which is what? 24. So I'm just going to write it, even though you don't have to, because it's mental math. What's 2 cubed? 8. Now what? And that's what? Yes, if you got one, give yourself a pat on the back. All right, seriously, guys, come on. Uh-oh. I know 41 is a nightmare. I know 41 is just awful. All right, so let me just go around the room real quick. Let's see who's thinking. 41. Mr. Valdez, you're up. Tell me what you got on. Oh, you weren't here yesterday. Why? What are you doing? What? There's a number that's coming out of your mouth. What number? What? You left my paper at school. That's not an answer. All right, next. Wallachek. You just didn't do it. Go. No, I want an answer. Yeah, some of you guys, that's what I'm saying. I asked you to do this, and this is what's going to cause a problem for you. I'm giving you zeros. Go. 41 is what? 15. I'm proud of you. Oh, what? Oh, you're telling me is it 8 divided by 8 0?
Oh, that's why.
All right. You said on the 41 what? 15. Next. Thank you. 47 over 72. Next. 70 what? Thank you. Next. 80. 6.5 over 12. Interesting, we put a decimal with a fraction. Sydney. 19 over 6. Well, is not a number. Well, I is still not a number. All I want is a number. No, that is not a number. That is a number. Thank you. Go. 16 over 9. All right, tell them the answer. 17 over 6. Uh-oh. What do we got? What? 2 and 2 over 6. Next.
26.
26. Why are we laughing? There's nothing. Look at the rest of them. I'm laughing at all of them if you want to know the truth. Amaya. 6. Ooh, okay. It looks like that's a winner. Next, Mallory. I wasn't here yesterday. Go.
5 over 18.
5 over 18. Someone who wasn't here probably got the right answer, correct? 5 over 18. That's a lot of garbage on my iPad here. Not going to lie. Get rid of all that garbage. Yes. I'm not paid to be nice. Here we go. 3/4 divided by 1/2. What am I supposed to do right off the bat? Turn it into a... What is this signal? I'm not doing signals. Multiplication. So 3/4 times what? No. 2 over 1. Plus 5, 6 times 1/3. Okay. So now we have to do the multiplication before we do the addition. So I'm sure everybody looked at this and said, 3/4 times 2 over 1. That looks like a really old problem from way back in 5th grade. I can pull out the 5th grade math book and show you. Yes. Wow. You said something intelligent. Let's go. What am I doing? Yes. So my answer here is what? Thank you. Thank you. If you're slow, that's right. All right. Now, can I do anything with the next multiplication? No. So that would be what? 5/18 plus 5 over 18. Now, a really dumb question. If I add that together, am I going to get 8 over 20? Some of you did. 8 over 20. Yeah, Miss Vaughn. Not me. I would never do something like that. You got what? I'm listening. Oh, that's much better. That was much better. We need a common denominator. 16 over 9. I don't know what you're talking about. What's the common denominator? 18. So I have to multiply the first fraction by what? 9. So that becomes, I know, yeah, 9 times 3. I saw you thinking about that. 27 over 18. Now I'm adding that together. What do I get? 32 over 18. And then I notice I can reduce that by a factor of 2. So those of you guys who said 32 divided by 2 today is 16 over what? 9. Those of you guys who said 16 over 9, pat yourself on the back. You have a good math teacher. The rest of you have an awful math teacher. All right. If you didn't get 16 over 9, awful. Yes, if you can't add fractions, I didn't do a very good job. I'm not going to lie. I take responsibility for all that garbage. All right. That's why we're not using calculators next year. All right. You think I'm kidding? I'm not. All right. Now, 42. Let's check out this garbage. Now, everyone, get busy. All right. I'm walking around the room, smacking the back of the head. All right. Getting you up and moving and going and getting this problem done. And don't give me some garbage like you just spit out at me. Let's go. Chop, chop. Oh, I see some of you rethinking your thoughts here. Yeah, slow down. Slow down. Take your time.
Are we supposed to do?
You're supposed to do 42. Are we supposed to do PEMDAS? You always do. You're doing 42. All right, you can't do those. You do 42. Try to get one of those right. I want to see your fractions. I see some of you with your neat handwriting. That's part of your problem. You're unorganized. All right, you're scatterbrained. You're just writing garbage on the paper. Write neat and organized. You'll become much more successful. As soon as you organize your life, you will be more successful. All right, you're writing stuff all over my paper, taking pride in nothing. Your parents pay a lot of money for you to come here. And you're writing sloppy stuff. Now, come on. I mean it. As I'm going from left to right, I'm going to do the multiplying and dividing in order from left to right. So everybody should look at the 7/15 and just write the 7/15 down. Now, what can I do to the 2 6s? Right, cross them out. Cross them out. So now that's just what? Negative 1/5. Come on, that is not that hard. Now I have to do the 4/5 divided by 3. So of course we just reviewed this. So I'm sure everybody in here did 4/5 times what? Times 1/3. Now don't embarrass me again. Come on. Everybody should look at that and say, that's what now? What does that multiply together? Yeah, 4 over 15 plus 4 over 15. All right. I don't know what you're talking about, but I'm on this step now. I already did that right here. Is this right here? Stop daydreaming. Thinking about your chickens. All right. Now I can't add these because I don't have a common denominator. So here, the 1/5. Everybody's smart enough to say, okay, 1/5 is obviously how many 15ths? 3 over 15. Now listen to me, guys, as much as I'm yelling, right? Hey, listen, if you don't know something, listen, I want to help you. If you're just sitting here writing down my numbers for a whole year, you did that. It didn't work out. So learn something now. You're a year older, a year wiser. All right? Ask. Now, I have a common denominator. So what's the final answer? 8 over 15. If you got that right, give yourself a nice little check. Oh, yeah. Now, mysteriously, since I didn't go around the room and everyone got the right answer now. Everyone. Isn't that nice? Right? That's why I don't like to do this. Uh-oh.
So when you got
42 or 41? What?
So. when you
Good
got
for
the
you,
15,
buddy. Yes.
Did you just see how many times it 15?
And multiplied it by 3. So look what I did. Come on. Shh. Hey, Miss Vaughn, zip it. Times 3 times 3. You see that?
Yeah.
All right. Yes. Now, everybody, knock out 43 and 44 while I answer the phone. 43, 44. All right, we're going to do a couple more before I get started with today's work. Hey, come on, stop. Nope. Yeah, I know. So I want to know what the answer is. What's 43? Go. 6. Oh, Miss Vaughn, let's hear yours since you got it right last time. No, for 75. Which one? 43. We're on that one. Give me the answer. Ooh. 6 was easy, right? Okay, okay. So now we'll do 44 and then we're going to go on. I'm just going to collect it. All right. Oh, someone be brave. 4 1/2. So let's do 4 1/2. I would prefer in advanced math, we say that's 9/2 from now on. We don't write mixed fractions. All right. Yes, that would be the other one. Tell me. 14/24. We could reduce that to 7/12. All right. Somebody else. Uh-oh, this ought to be good. Oh, so 9/2 might be the answer. Anybody else want to throw an answer up here? What'd you get? Didn't you already say that? Okay. Not. All right, here we go. So 3/4. What's X times Y? What's X times Y? 12. Minus what's Z? Oh, wow. 12 minus 6 is what? 3/4 times 6/1. Now we reduce. What goes into 6 and 4? 2. That becomes a, and this becomes a. So 3 times 3, 9/2. If you got that right, seriously, give yourself a little pat on the back. Now, again, listen to me. What I want to do is this. My apologies, but listen, I'm going to collect this tomorrow. All right. Because those of you guys who didn't do it, I'm telling you, you are going to get zeros. And I'm going to start calling your parents. All right. So I don't want any trouble. All right. I'm telling you, there's not many grades. And if you don't do your homework, your grade is going to be way less than it should. All right. Because normally we have a whole bunch of grades. So if you miss a couple assignments, it's not really a big deal. All right. But if you don't have a lot of assignments and you don't do your homework, then your grade will be terrible. All right. Is everybody with me? All right. So with that being said, I'm going to pause the video. I'm going to pass out the next thing. And then today, I said, those guys who are finally listening, I will collect both of these work tomorrow. All right. Both the work. All right. So the assignment that you didn't finish, some of you, all right, I appreciate it if you did. All right. But there was a lot of people absent. So we're going to give it a little bit extra time. All right. Now, for today, we have just a lot of memory work. All right. And what I mean by that is you just have to understand the names of the properties. You have to know the names of the sets of the numbers. All right. So with that being said, the commutative property. All right. Commutative property simply says A plus B is the same as what? B plus A. All right. Now you can also say A times B is equal to B times A. Those are examples of commutative property. So the order in which you add doesn't matter. The order in which you multiply does not matter either. So everybody make sure you write that down. All right. Now, the associative property. Associative property is how you are grouped. All right. So for example, an example of that would be A plus B plus C. That is going to give you the same result as if you take A and you add B plus C first. That's the example of associative property. Now, what I want you to do right underneath that is I want you to write the example for multiplication. What would be the example for the associative property of multiplication? Again, you should have been writing AB in parentheses times C is equal to A with parentheses around the BC. Now notice the associative property. Is the order in which you list the variables the same? And that would be a yes. A, B, C, A, B, C. They're in the same exact order. Does everybody agree with that? As soon as they're out of order, it's called a commutative property. A, B, and then B, A. They're out of order. So that's the commutative property.
Yeah, community, it matters.
No. Yes, it does. That's why there's no commutative property for division. Yes, you see what I'm saying? 1 over 2 is not the same as 2 over 1. All right. Now, the additive identity. All right. The additive identity says this. What do you add to remain the same? 0. Thank you for that. So the additive identity, we're going to write x plus 0 equals what? X. That's exactly correct. Now, right underneath that is the multiplicative. Instead of property here, cross that out and put identity. That's my first typo. The multiplicative identity. Please change that to identity. And then write the example for multiplicative identity. And then tell me what that is. Shh. So if you multiply by 0, you get the same answer. Times 1. So your example for multiplicative identity should be x times 1 equals what? X. Beautiful. Now, inverses, they cancel out. Inverses cancel out. So how do you cancel out x? You add negative x. All right, you add negative x. All right, so when you're adding the opposites, all right, x plus negative x, that will always equal 0. All right, when you add the opposite, they cancel out. Now, the multiplicative inverse, sometimes a little bit harder. So how do I cancel x out with a multiplicative inverse? No, that's close. All right, I like your thought process. But the multiplicative inverse is x times 1 over x. That equals 1. All right. That's an example of the multiplicative inverse. When things cancel out, they're inverses. When things cancel out, they're inverses. All right. Now, the distributive property. I want everybody to look up here on the board. If I wrote 2 parentheses x plus 3, that distributive property would be 2 times x plus 2 times 3. All right, so this would just be 2x plus 6. All right, that's an example of the distributive property. So here's the real thing though. A, open parentheses, B plus C. This would be the example that I want you to write down. So that answer would be AB plus AC. All right, that's the example of the distributive property. Distribute means you multiply over the addition. All right. And now our last property is the 0 property. You might tell me what the 0 property is? Yes, sir. You are brilliant. X times 0. Anytime you multiply by 0, you always get what? You always get 0. All right, so those are the properties you should know. Those are the properties that you should know. All right, now we have to define the numbers. Natural numbers. I want everybody to put down, it is abbreviated with an N. Does anybody know the natural numbers? Yes, it is. I'm proud of you, girl. 1, 2, 3, ... What does ... mean? Yeah, it goes on to infinity. All right, it goes on for infinity. All right, now the whole numbers we're going to use as a letter W to abbreviate. And who knows the difference between a natural and a whole? What was it? You're a very smart girl. 0, 1, 2, ... All right, so the only difference between a whole number and a natural number is 0. All right, now integers. Does anybody know what letter that is? I, of course not. Sorry, hold on. It's Z. For some reason, they chose Z to be the abbreviation for integers. All right, the people who wrote this a long time ago. Now, listen, how you define integers are whole numbers and their opposites. That's right. So everybody's going to write down ... -2, -1, 0, 1, 2, ... So the definition of integers are whole numbers and their opposites. Whole numbers and their opposites. All right. Rational numbers. We're going to abbreviate rational numbers with the letter good. Q. Yes, I don't know why. All right. Q. All right. Rational numbers. All right. Now, rational numbers, I want you to write this down. All right. Any number that can be written as a fraction. Any number that can be written as a fraction. All right, any number that can be written as a fraction. Everybody's okay with that? All right, so believe it or not, all right, here's how you think about this. If you are a rational number, hey, everybody's got to listen. If you're rational, you're also an integer. You're also a whole number. You're also a natural number. All right. Because can an integer be written as a fraction? Can the number 2 be written as a fraction? 2/1, 4/2. You with me? So every single one of these numbers right over here, they can be written as a rational number. Now, if you're an integer, then you're also a what? If you're an integer, you're also a what? Whole number, and you're also a what? Natural. If you're a whole number, you're also what? Natural. You with me? What? No, I'm just saying this. Listen to me carefully. Let me say this one more time. If you are an integer, all right? No, I'm sorry, man. I did that totally backwards. Boy, that was a big mistake. I'm sorry, guys. If you're a natural number, then you're automatically a what? Whole number. If you're a whole number, you're automatically a what? And if you're an integer, you're automatically a what? There you go. Can you be rational without being an integer? Yes. For example, 1/3. 1/3 is a fraction, correct? But is it an integer? No. All right, it's not. All right. So if you're a whole number, all right, if you're a whole number, and again, that's what, if you flip the page, look at how much practice we have. All right, we have lots of practice. All right, because it's important. All right, now let's look at, before the day ends, let's look at irrational. If rational means you can be written as a fraction, irrational means you cannot be written as a fraction. Thank you. All right, and the abbreviation is this, IR. All right, for irrational. All right. Any number that cannot be written as a fraction is irrational. Any number that cannot be written as a fraction is irrational. And all numbers are real numbers. When you get to algebra 2, they will talk to you about imaginary numbers. Fascinating. All right. So you have two sets, real and you have imaginary. All right. But right now we are only studying the real numbers, and all of these numbers are considered real numbers. Now, let me give you a quick example of an irrational. Can you tell me the most famous irrational number? Yes, right. Very good. Pi. What else? E. All right. You'll learn about Euler's number. All right. When you get into pre-calculus and algebra 2. And then there's also square root of non-perfect squares. So if I said the square root of 5, or if I said the square root of 31, those would all be examples of irrational numbers. Yes, ma'am, quickly. Real numbers is this. That's a good question. Watch how I do it. One line, one line. That's the symbol for real numbers. All right, that's the symbol for reals. All right, what time do we get out? We got 5 minutes in, right? Is that what you're telling me? 12:11, right? Or yeah. So we got 5 minutes. All right, so that gives me time now. All right, number 1. That's the example of commutative property. Now you can write this down. COMM, and then it's commutative property of addition if you want to abbreviate. What are we doing with number 2? Yes, associative property. Now make sure you abbreviate properly. Associative property of what? That's what you're writing down if you want to abbreviate. What's number 3 called? Yes, it's multiplicative identity. Number 4. Nope. Additive what? Identity. That is correct. Additive identity. Number 5. Things are canceling out. Additive inverse. Number 6. 2/3 and 3/2 is canceling, so it's a what? Inverse. That's right. Multiplicative inverse. Uh-oh. Number 7. That's correct. Very good. Distributive. And what about number 8? Say it. Yep, it is the distributive property. All right, what about number 9? There's multiplication involved. That's right. Multiplicative inverse, because things are canceling. What about number 10? Nope. Identity, additive identity, because you're adding 0. Number 11, commutative property of addition. And then 12, associative property of multiplication. 13, additive inverse, thank you. 14. Yes, I'm proud of you, girl. Associative property of addition. Uh-oh, 15, what am I doing?
Multiplicative inverse.
You are awesome. Multiplicative inverse. Number 16 is what? I tricked you. I tricked you. Yep. Notice here, x plus one. Yes. No. Look. X plus y and y plus x. The order is changed. Whenever the order is changed, we're dealing with the commutative property. All right, commutative property. What's 17 called? Zero property. Thank you very much. Okay, flip the page. 5 is a what? Natural number. Okay, here's what I need you guys to do for me. I want you to finish all the way up to 34. All right, finish all the way up to 34. All right, the last 2 pages are like extra practice. All right. Hey, that was a good job today, guys. I appreciate it.
Yesterday's homework, what should I go up to?
All of it.